Okay, so now we're going to look at inverse. Okay, so let's go back to the basics. The inverse in math is the operation that will undo, or something that undoes what has been done. So for instance, with our operations, addition and subtraction are inverse. So if I have x plus 3 minus 3, I'm adding and subtracting the same thing. I get back to x. So adding 3 and subtracting 3 are undoing each other, getting me back to what I started with. Similarly, multiplication and division are inverse. Squaring and square rooting are inverse, and exponents and logs are inverse, as long as the base is the same. Okay, so then if we're thinking about inverse functions, if we take a function, let's say we have y equals 3x plus 2. If I switch my x and y, x equals 3y plus 2, and then solve for y, subtract 2, so x minus 2 equals 3y, divide by 3, divide by 3, so I have x minus 2 divided by 3 equals y. This function and this function are now the inverse of each other, and we can show that because if I substitute this in, they'll undo each other and I'll get back to x. So if I say y equals 3 times x minus 2 divided by 3 plus 2, and then I get y equals x minus 2 plus 2, so I get y equals x. So if I use the inverse function as the input and then simplify, I'm just left with y equals x. Okay. So this is when we're finding the inverse function. So on your assignment, there's a problem y equals log base 3 of 4x, and it asks you to find the inverse. So for this one, I'm going to reverse the x and y. So I'm going to say x equals log base 3 of 4y, and then I need to get my y isolated. And in order to do this in this case, I need to rewrite this in exponential form. There's nothing to add or subtract at this point, so I have 3 to the x equals 4y, and let's do a quick revisit of log form. So if we have a base to a power equals a number, then the log version of that is log base b of a number equals the exponent. So that's kind of the pattern of going back and forth between logs and exponents. Okay, so now I have 3 to the x power equals 4y. I can divide by 4, and I end up with 3 to the x divided by 4 equals y. Or I could write that y equals 1/4 times 3 to the x, and that's more likely how you're going to see it. So these two functions are inverse of each other. Okay. The other idea with inverse functions that I want to make sure that you're clear on, let me get this centered again. Okay. Is looking at the graphs. So remember that because we're changing x and y, the graphs of inverse functions are reflections across the line y equals x, because we're basically just swapping the points x and y. So if I have an exponential function that looks like this, and let's say this point is at 0, 3, and this point is at 2, 9, then I can find the reverse of that. So now I'm going to have a point at 3, 0, and I'm going to have a point over here at 9, 2, and there's my new function. Okay, so our inverse, and I did not draw that to scale at all, but our inverse functions are reflections across here where we're swapping the x and y values in the graph. All right.